everyone, this is Ziyue Zhang. I'm going to take the first part for the presentation and to tell what the null and alternative hypothesis that the project 2 is testing. For the null hypothesis there is no significant relationship between total volatility and expected stock returns. In other words, changes in total volatility do not have a systematic effect on stock returns. And the alternative hypothesis is there is a significant relationship between total volatility and expected stock returns. It implies that changes in total volatility are associated with systematic change stock returns either positively or negatively. By conducting univariate portfolio analysis, the project seeks to assess whether investors can earn significant returns by investing in a volatility long-short portfolio. There is entails examining whether the volatility of stocks as measured by total volatility can be exploited to generate abnormal returns. Thus, the null hypothesis assumes that no exploitable relationship, while an alternative hypothesis suggests the presence of such a relationship.
Hello, I'm Weidi Wang. Next, I will talk about the second part. What's the methodology of the portfolio construction and how it's implemented in project CodePace. This project is mainly based on the volatility of stocks and compared with the return rate of stocks to build investment portfolio. The first is the code for the ETL part. This part of the code, I will divide it into 4 parts to introduce. First, import module. Second, read stock price data. Third, calculate daily and monthly returns. Fourth, generated income dictionary. Import module. The code first imports the required modules, including pandas, as well as project-specific configuration and tool module. Reading stock price data. The function is used to read stock price data for a specific time period from a CSV file. This function takes the ticker symbol, start date, and end data as arguments, and returns a panda series containing the adjusted closing price. Calculate daily and monthly returns. The daily return and the monthly return function receives the stock price sequence returned by read the file and calculates the daily and monthly returns. This function outputs another panda series with a daily yield and a monthly yield. Generate income dictionary. The dictionary function generates a dictionary containing the daily and monthly returns of all specific stocks. The dictionary has 2 keys, daily and monthly, each corresponding to a data frame containing the corresponding yield data. The second part is the code for the main part. This part of code is mainly used to construct a stock portfolio based on the volatility of the stock. This part is also mainly divided into 4 parts. First, browse documents. Second, main function. Third, auxiliary function. Fourth, draw conclusion from the analysis. The main purpose of this section is to browse and record the documents in the pandas database for subsequent computational analysis. The main function of the code integrates data collection, data processing, data analysis, obtaining data from ETL.py, calculating stock volatility using CHA.py, and analyzing data and build a portfolio through pf.py. Third, provides some auxiliary function for calculating the average of stock price and cumulative returns. Fourth, the data obtained above are calculated and analyzed to draw conclusions. The third part is about the code for the portfolio section. This part of code is mainly used to calculate the volatility of the stock and combined with the monthly return and analysis. First, the citing function is used to check whether the input data is reasonable and ensure that the data meets the function requirements. Second, calculate the volatility of each stock each month. Third, combine the data of stock volatility with the data of stock monthly return.
My name is Yu Zhang, and next I will introduce the part 3. I will elaborate on it from 4 aspects. First is significant testing. When accessing the significance of the relationship between stock prices and stock volatility, the t-value of 1.3847 falls below 1.96. This indicates that we cannot reject the null hypothesis, suggesting no connection between stock prices and volatility. Therefore, based on this t-value, we can now conclude a link between the two variables. Utilizing t-statistics for hypothesis testing aids in determining if the average returns from the portfolios significantly differ from zero. With a t-statistic of 1.3847, lower than 1.96 for a 95% confidence level, we fail to reject the hypothesis, suggesting that the average returns from these portfolios are essentially zero. Secondly, the market efficiency. The average returns from the portfolios at 0.0242, significantly differing from zero, may imply the presence of non-random movements in market prices, indicating potential market efficiencies. Third is investment strategies. The return of 0.0242 from long-short portfolios significantly differing from zero may indicate a preference for long positions over short positions in investment strategies. Finally, regarding the volatility long-short portfolios, the cumulative return of 1.5980 demonstrates a positive outcome, signifying profitable results from the strategy. Beyond the returns, it is essential to consider risk-adjusted returns when evaluating long-short portfolios. Evaluating the risk-adjusted returns of these portfolios, offering insights into the attractiveness of investment strategies. A favorable cumulative return combined with volatility suggests strong performance in terms of risk management. Thank you.
Hello everyone, my name is Yuanhao Du. Now I talk about the fourth questions. Is our data reliable or not? Firstly, let's talk about the p-value. I think it is the most important element when we talk about is the statistical result reliable or not, or rejected or not, is the p-value and the p-statistic. As you can see here, I did some calculation. I didn't do the calculation in the project for the p-value, but as you can see here, the p-value is 0.1674, and the t-statistical is 1.3847. These numbers are the crucial because they will help us to determine whether the result we observed could have happened by chance. The p-value in particular will tell us there is a 60.75%. Chance that our portfolio means return could be 0 or less under the window conditions. This does not meet the typical threshold for significant, which is 5%, indicating that our finding is not statistically significant, and it also suggests that we should be caution when we consider this data.
Hi everyone, it's Ziyue Zhang again, and I'm going to take over the last part for the presentation to show the further work for Project 2. And I have just listed a to-do list for what to do, and it has 8 parts. The first one is multivariate analysis. Expand the analysis to include factors beyond total volatility that could influence stock returns, such as market factors, sector-specific variables, or macroeconomic indicators. This could provide a more comprehensive understanding of determinants of stock returns. And the second one is robustness check. That conduct robustness checks to validate the findings obtained from univariate portfolio analysis. This could involve testing the sensitivity of results to different portfolio constructions, methodologies, time period, or sample composition. And the third one is advanced statistical techniques. Explore the application of advanced statistical techniques such as time series analysis, panel data method, or machine learning algorithms to enhance the accuracy and predictive power of the models used in analysis. And number 4 is risk management strategies. Develop and evaluate risk management strategies based on insights gained from the analysis. This could involve designing portfolio optimization techniques to minimize risk while maximizing return, or implementing hedging strategies to mitigate downside risk. And next one is real-time monitoring. Implement a real-time monitoring system to track changes in total volatility and assess their impact on stock returns dynamically. This could involve developing automated alerts or dashboard to notify investors of significant developments that may affect their investment decisions. The next one is peer comparison. Compare the performance of the volatility long-short portfolio constructed in this project with those of other peer strategies or benchmarks. This could provide insights into relative effectiveness of the strategy in generating alpha compared to alternative approaches. And next one is publication and presentation. Prepare a research paper or presentation summarizing the findings and insights obtained from the analysis. This could involve documenting the methodology, results, and implications of the study for dissemination to academic or professional audience. And the last one is feedback and collaboration. Seek feedback from peers, mentors, or industry experts on the analysis conducted and incorporate their suggestions for improvement. Collaborate with domain experts or researchers could also enrich the analysis by bringing in diverse perspectives and expertise. And for the last, in conclusion, by pursuing these tasks, we can deepen our understanding of relationship between total volatility and stock returns and explore avenues for enhancing investment decision-making and portfolio management strategies. And that's all for our presentation. Thank you for listening.